Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to be discussing the common characteristics that are used to compare graphs in graph theory. For various reasons, when we look at two graphs, we need to be able to determine how they're alike and how they're different. Some very basic yet important characteristics which we can use to determine this are the number of edges, the number of vertices, the degrees of the vertices, and the types of cyclic subgraphs contained in the graph. Let's start with graph L and graph M. So how many edges are in graph L? Let's count. We have 1, 2, 3, 4, 5 edges in graph L. We have 1, 2, 3, 4, 5, 6 edges in graph M. So graph M has one more edge than graph L. Now let's compare the number of vertices. Graph L has 1, 2, 3, 4, 5 vertices. Graph M has 1, 2, 3, 4, 5, 6 vertices. Now let's compare the degrees of the vertices. Remember, the degree of a vertex is the number of edges that meet at that vertex. So in graph L, we have vertex A, which has 3 edges connected to it, so it has degree 3. Vertex B has degree 2, C has degree 2, D has degree 2, and E has degree 1. So graph L has vertices of degrees 3, 2, 2, 2, and 1. Now let's look at graph M. Vertex F has degree 2, G has degree 2, H has degree 2, J has degree 3, I has degree 2, and K has degree 1. So graph M has vertices of degrees 2, 2, 2, 3, 2, and 1. 4 vertices of degree 2, 1 of degree 1, and 1 of degree 3. Finally, let's look for any cyclic subgraphs. Remember, a cyclic subgraph will travel from one vertex through a sequence of vertices, never hitting any vertex or edge twice, and returning back to the original vertex. So in graph L, we have a cyclic subgraph of size 3 that travels from A to B and then to C and then back to A again. There are no other cycles. This is a 3-cycle and also known as a triangle. Let's compare that to graph M. In graph M, we can see a cycle that goes from F to G to H to J and back to F again. F, G, H, J is a 4-cycle or quadrilateral. So while graph L has a triangle or 3-cycle, graph M has a 4-cycle or quadrilateral, which is a significant difference in the underlying structure of the two graphs. If two graphs represent the same pattern of connections between the same number of objects, then we say they're isomorphic. It can often be very challenging to determine if two graphs actually are isomorphic. We'll frequently begin that process by trying to eliminate the possibility of this relationship by showing that they either differ in the number of edges or vertices, in the degrees of the vertices, or in the types of cyclic subgraphs they contain, to show that they're not isomorphic. In this example, we're asked to identify a difference between the pair of graphs that demonstrates the two are not isomorphic. We're going to do this by considering the 4 characteristics: the number of edges, the number of vertices, the degrees of the vertices, and the types of cyclic subgraphs. So let's start with the number of edges of graph Q and the number of edges of graph R. Graph Q, we have 1, 2, 3, 4, 5, 6, 7, 8 edges. And for graph R, we have 1, 2, 3, 4, 5, 6, 7, 8 edges also. So far it's possible they could be isomorphic to each other. They could represent the same relationship between the same number of vertices. Let's count the number of vertices. 1, 2, 3, 4, 5, 6, 7, 8 in graph Q. 1, 2, 3, 4, 5, 6, 7, 8 in graph R. Identical. Let's move on to the degrees of the vertices. So we have have in graph Q, vertex A has degree 1, vertex F has 4 edges connected to it, so it has degree 4, vertex G is degree 1, B is degree 2, E is degree 4, D is degree 1, H is degree 2, and C is degree 1. So graph Q has 4 vertices of degree 1, 2 vertices of degree 2, and 2 vertices of degree 4. Let's check R. Starting up here at vertex M, we have a vertex of degree 1, and then 4, and then 1. Vertex O has degree 2, N has degree 2, P has degree 4, J has degree 1, and K has degree 1. So once again, graph R has 4 vertices with degree 1, it has 2 vertices with degree 2, and it has 2 vertices with degree 4. So far, it seems like the graphs are identical. Now let's consider the types of cyclic subgraphs. So in graph Q, there's really only one structure that loops back around. Remember, a cycle loops back around. So I'm going to highlight it here. So here we see B to E to F and back to B is a cyclic subgraph, and it has 3 vertices. So it's called a three-gon, or you can call it a triangle. For graph R, I also only see one place in which the graph loops back around. I'm going to highlight it here. So in this case, it goes from I to N to P to O and back to I again. So this actually has 4 vertices. This is a four-gon or quadrilateral. Okay, so since these two have different sizes of cyclic subgraphs, they cannot represent the same relationship. So we would be able to conclude that since they have different cyclic subgraphs, they are not isomorphic. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video. You can also subscribe to my channel, Miss Earn Mathematics, for more math videos.